Alright, SM2. This is gonna be more of a extra assignment. So the assignment itself is gonna be extra credit, but it's very important information, and we're gonna go over it in class as much as we can. It's gonna be very much needed in some of SM3, so I recommend that you complete this assignment. But we're talking about systems of equations. So let me talk about what a system of equations are. Okay, so I'll do this on just like a blank page, and you don't necessarily have to write this down. But so let's say that we have a coordinate plane. On an x and y graph. Okay. Now, systems of equations is when you have two or more equations existing on the same coordinate plane. So for example, let's say that we have two linear functions. Okay, so here are two linear functions. The blue function is represented as y is equal to some mx plus b, some linear equation, and y is also equal to mx plus b, but obviously they aren't of the same m and b values, right? So this is what a systems of equation looks like. It's with two or more equations. Now what we're going to be doing today is we're going to be solving a system of linear equations. Now what that means, in particularly, when it says to solve a system of equations, it's asking you to solve where they intersect. So like right here, these two linear equations intersect at this point right here. So this is some point xy. Okay, and so what we mean when we solve for a systems of linear equations, we're going to solve for the value of x and the value of y where these two equations intersect. Okay, so that's what we're learning in this right here. And there's different methods to which we're doing it. Now, hopefully by the end of the year we can talk about an alternative method, but today we're going to focus on the method of substitution. Okay, I'll show you how you do substitution. So usually in a systems of linear equations, when you're solving, something that we usually like to do, it doesn't always have to be this case, but we usually like to write our systems of equations where we line up the x's, the y's, and the constants. Okay, so we have x's, y's, and then equal sign and constant. Okay, so it's not written in slope intercept form. Okay, I think this is actually standard form for a linear equation, I believe. Let me actually look that up, just to be sure. Yes, this is a linear standard form. So whenever we solve systems of equations, especially whenever they're linear equations, we like to have the linear equations written in standard form, which is ax plus by equal to c. Okay, so most of these or all of these should have that set up, but in any case, so when we solve by substitution, here's what we want to do. We want to pick a variable, x or y. Okay, it doesn't matter which one. Now, it does matter in terms of which would be easier to solve for, but we want to pick one, x or y, and solve for that x or y variable. Okay, so in this first one right here, I want to pick x or y in one of the equations. Okay, so I don't really have space. If you guys have extra paper, so first step would be pick a variable. Pick a variable x or y to solve for in one of the equations. in one of the equations. Okay, so pick a variable. So just be careful in the sense that we want to make it easier for us. So I don't think I want to solve for y in either of these ones because they have a coefficient next to them, which wouldn't typically be easy. But you see that in the x's here both have just a -1 coefficient. It would be much easier to solve for. Now I'm going to choose this one right here. Okay. Now remember to only choose one of them. You don't need to do it for both. So I'm going to take this equation right here, and I'm going to solve for x. Now to solve for x, I mean to get x by itself. So I'm going to add x to both sides of the equations. And when I do that, I eliminate x on this side, and it puts it onto this side right here, or adds one over there. And so my equation then would look like -3y is equal to x. Let me put it in this way right here. I'll have x is equal to -3y. Okay, now this is what I'm going to substitute. This becomes my substitute. This is my substitute. Okay, so this leads to my second step, which is take the substitute and substitute it into the other equation. So this step you got to be careful about, that you don't put it back into the equation that you just solved for, okay? So I can't take this x equals 3y and put this back. So I can't take, so right here, we're going to substitute in for x. So I can't take this x equals value. I can't put that in here. It won't work out that way. I can't put this back into the equation that I solved for. I need to take my substitute, and I'm going to take this x equals -3y and plug it in right here. So negative, and instead of x, because x is equal to -3y, I'm substituting -3y minus 4y equal to -1. Okay, now let's clean this up a little bit. See here that I have a negative and a negative, so it's going to be positive 3y minus 4y is equal to -1. Okay. Now, what this means right here is I can combine these like terms, because now I no longer have an x variable. I just have one equation with one variable, which means I can solve for that one variable. I no longer have two variables. So when I combine these like terms, -4y and positive 3y, I get -y equal to -1. And if I want to make y positive, I just have to divide by -1 or multiply both sides by -1, but in either case I get y is equal to +1. Okay, so I kind of skipped over that next part. So I take the substitute back in. 3, solve for the one variable. So in this case, we solved for y. Okay, so I know that y is equal to 1. Okay, that doesn't mean we're finished. Okay, now remember our goal here. I'm trying to find the point. I have found this point so far. I found that y is equal to 1. Now I need to find the value of x. But here's the thing, I know the value of y at this point. So what that means I can do is I could take the y and I could substitute the y into either one of these equations. It doesn't matter. Doesn't matter which one. Okay, so for take known variable and plug it into either equation and solve for remaining variable. Okay, so take the known variable, plug it into either equation, and solve for the remaining variable. Okay, so I can take y is equal to 1, plug it into either of these equations, and solve. So I'm going to plug it into this one right here. So I have negative x minus 3 times by 1 equal to 0. Now, if I solve for this, so notice that I now eliminated the y variable, and that's left me with only the x variable in this equation, which means I can solve for x. So I get negative x minus 3 equal to 0. Let me add x to both sides, and I'm going to get positive x is equal to negative 3. So my solution is negative 3 comma 1. So these two lines these two linear equations are going to meet, or going to intersect at the point negative 3, positive 1. Okay, at negative 3, positive 1. Pretty cool. Okay. And that's pretty much it for this one. You just need to follow these steps, honestly, that I have outlined here. Okay. Now, again, I'm going to make this an extra credit assignment. I'm going to cover it in class as much as I can. But anyways, so extra credit assignment, it will count as extra credit towards your homework, and there might possibly be an extra credit question on the test as well. That will come from systems of equations, okay? But this should give you enough practice that will help you solve systems of equations when provided two linear equations. Okay? Alright, and that pretty much does it for this one. Thanks, guys.